In this video, I'll be setting up a simple wing rig. So what I've got here is a simple FK setup for the wing. So if I go ahead and rotate the FK controllers, you can see that I have skinning already on the creature itself. There's an infinite amount of ways to rig a wing. I'm going to do a very simple setup, and I'm gonna have each feather follow the nearest joint with a fall off towards the next joint in the chain. One thing you can do to start out is to create a simple surface representing the shape of the feathers. This can especially be useful if you're animating several creatures and want to have a simple proxy version of the feathers that doesn't weigh too much on the system. You could also decide to use this as a basis for driving your feathers. You can decide to use follicles to constrain your feathers to the surface of this geometry. By doing this, you would make it very easy to control the influence from each joint on the wing. This is because you would only have to deal with one skin cluster for the entire surface of the wing, instead of one skin cluster for each feather. Now that I have the proxy wing modeled, I can create a few joints to control the bend and twist of the wing. With a setup like this, it should be easy for the animator to block out the action. Now once you're sure you have all of your feather proxies modeled and placed out, it's time to create the guide curves. If you have different types of geometry proxy feathers in there, you might want to create the guide curves in more than just one go. So let's select the feathers we want to start out with. We'll add a skin cluster to these feathers in a minute, but first let's go to the script editor and run the create guide curves script. Now I already checked the vertex ID of one of the feathers and put it in my script. Since I told my script which vertex on the feather instance to draw the guide curve from, and since the feathers are all copies of the same original feather, it should draw the guide curves in a predictable way across all of the selection. Checking my new curves, I can see that there are only 2 strays. So since it's a manageable number, I'll go in and manually correct those 2. So I'll just snap the curve points to the vertex points that it was supposed to have used. Since my proxy feathers are comprised of different pieces of geometry, I need to do the same process for a new layer of feathers. Since this layer of guide curves is only going to be based on 4 vertex points, I'm going to take out the 5th vertex query. Now I'm going to go through and check the vertex ID for the current layer of feathers. I use the Maya callback window to return the value that I want. In this case, I can see that the vertex IDs are the same as in my script currently. Since I've removed a vertex from the equation, I need to go into the curve line and remove one of the not values. I will also need to remove one of the point values. I'm of course removing the value that was queried in the line above that I deleted. If the curve command receives too many or too few values, it'll produce an error. Again, selecting all of the feather instances and running the script will give me some guide curves that I can work with. As an example of how it could go wrong, you can see that the final feather, the outermost feather, is missing one edge loop. This means that the geometry is different from the rest of the feathers, and thus the vertex ID is different. Since this one feather instance has a different vertex count, it also has different vertex IDs. That is why in the script, as we hard-coded the IDs from specific numbers 0, 2, 3, etc., those numbers don't match up any longer, and that's why it creates a curve that is very unpredictable in shape. With this rig, we are creating a very simple setup that doesn't allow for too much control. Ideally, in a high-end production environment, you would have a joint chain for each feather hooked up to an IK-FK system. With this, the animator would be able to control how sections of the wing or individual feathers should behave in the animation. This is not to be underestimated, as some feathers are not as stable as others, and in a realistic situation, some feathers may wobble more than others. Creating such an advanced setup is crucial in order to get a realistic result, and it will make it easier for the animator once he or she reaches the polishing stage. For this rig, in order to keep it simple, and since it's not going to be animated as such, I'm going to create only a few joint chains. I'm then gonna skin my feather geometry and my guide curves to the joint chains, and I'm gonna make sure that there is a decent fall off in between them when the wing is rotated. As you create your guide curves, you might also want to put them in a set. If you put them in a selection set, we can use them later when we do our groom. You don't have to do it now, but you might as well. What I've done in this rig now is to simply parent constrain the joint chain to the controllers. So in this case, I'm having two parents constrain one object. This gives me a nice 50-50 fall off for now. Now select the joint chains and then select the geometry and your guide curves, and skin the whole thing. Since you cannot paint weights on guide curves, you need to go into Window, General Editors, and Component Editor. Once in here, you can select components of your curve and tweak the influence of each joint. In order to change influence of joints that are not currently affecting your curve, you need to go to Options. From the options menu, you can go and check off the Make Zero Columns tab. This will show the items that are not currently affecting your guide curve, and you can add values to those. So from in here you can tell the curve points to follow certain joints by a certain amount. In this case I'm going to have this curve follow the joint on each side by 50%, so I'll set it to 0.5. Remember that a skin cluster value should never exceed 1. 1 is 100%, and if you allow values above 1, you can never know if something else is affecting your point. That's why it's good to know that 1 is the maximum and nothing else has influence on this object. If you create a joint chain for each feather where the joint is placed on the same point as the vertex or the point of the curve, then you shouldn't have to go through this process, because when there's a dedicated joint for each point, then the automatic skinning should work just fine.